Hi, Assalamualaikum. Alright, so today we're going to continue with our lesson, and our subtopic today is 6.4 thin lens formula. So what is thin lens formula? Actually, thin lens formula is another formula or another equation that can be used to solve lens problem or lens situation lah. Alright, so the example is given in your textbook, okay, starting off the 6.4 subtopic. So in photograph 6.4, it shows the position of camera lens from object. So this is actually the picture or the images taken by using the same camera. If you check the first one, you can see the object is close, or you have a large image. For the second one, you have a smaller image compared to the first one. Why you have these two different image? Okay, I know all of you have experience, okay, using a camera. You know how to produce this bigger image compared to the other one. This is because where you position your camera. Okay, so inside your camera, there must be lenses, okay, or a lens at least. So position of camera lens will determine how large the object will be produced. Alright, so the first one is, of course, the object is closer to the lens. The second one, the object is a bit further from the lens. Alright, so the thin lens formula, as you can see, it is 1 over f equals to 1 over u plus 1 over v. So FUV is not something new. Okay, it's not the new thing. Okay, it is actually represent the same meaning as we learned in previous video. So F stands for focal length. Alright, so let me write it for you. So S, still, it is still focal length. Okay, alright, what is U? I know you know what is U. So U is the object distance. Alright, so while V is the image distance. Alright, so we lost that. Okay, let's go back to the thin lens. Please excuse the screen for a while. Alright, it looks like we have jumped few pages. Right, so this is V. Okay, back to the meaning. It is the image distance. Okay, so when you have this kind of formula, it is called thin lens. Okay, it's a thin lens formula. Okay, so this is actually an experiment that we're supposed to conduct in school later. So I will explain on the experiment later. Okay, or you can check the demonstration of this experiment with this QR code. Okay, you are at home, you have your textbook, you have your handphone, so you just scan that and take a look at the demo. Alright, so let's go back to the solving problems using thin lens formula. So table 6.10 is the important sign convention that you need to understand. So the sign convention, there's only two. It's positive or negative. So positive is representing convex lens. Okay, and negative is concave lens. So when you go to the supermarket, when you see the, you know, when they sell the, what do you call that? The spectacles, okay? Cermin mata. So there's a sign of positive and negative at that lens, right? So you know the positive represent the convex lens and negative is the concave lens. So which is which, and which one is for the which? The, you know, the vision impaired, that you can check on your own. Okay, so go and Google and explore the type of lens and the type of vision impaired. Okay, for positive also represent for the real image. That means when you do the calculation using the thin lens formula, when you get the value of V is positive, that means your image is real. Okay, so while when you do the calculation, let's say it is 1 over F, 1 over U, okay, plus 1 over V. Okay, when you do this calculation and then the question asks for V and you do your mathematics, let's say you got the answer is negative 0.2. Right, so this is cm, for example. If you got this kind of value that is negative, right? So when your value is negative, that means your image is virtual. Okay, when your image is virtual, the value in the calculation should show the negative sign. Okay, if you do your calculation using 1 over f, 1 over u, 1 over v, and then you got your v value as positive 2 cm, for example. Okay, the positive sign. When you got positive sign for the image calculation, that means your image is real. Okay, like we said earlier, what does it mean by real and virtual? That means your image is formed on the right of the lens or on the left of the lens. So if you forgot about that, you can go and watch the previous video on the real and virtual image. Okay, so one more thing, it says if it is positive, it is on the opposite side of the object. If it is negative, it is on the same side of the object. So normally it is only happen to the concave lens, because this is concave lens, right? So if you have your object here, normally your image will form on the same side. This will be your image, maybe here. Alright, so but for the convex lens, normally if it is the object, then you will have image on the opposite side. That means it is on your right hand side. For this one, your image will be on the left hand side as your object position. Okay, so that is basically the sign convention that you need to master in order to do this calculation. Because if you check the example given in your textbook, okay, so this is very simple one. So let's check on example 1. If your screen is blurred, it is because YouTube didn't give me the high resolution of video yet, because maybe the way I'm recording this video. So what you can do is to check your textbook. It is on page 261. So check example 1. Okay, a thin convex lens has a focal length of 12. Determine the characteristic and the position of the images formed and linear magnification when the object distance is 18 cm. That means there is not just a thin lens formula, there is also a linear magnification formula, because the question asks you more than one thing. Alright, so first thing, when you got the question, okay, let me okay, so a thin convex lens has a focal length of 12 cm. So remember, the convention for the convex lens is positive, right? So that means this is your f with the value of positive 12 cm. Right, so determine the characteristic and the position. Okay, the characteristic is not something you calculate, so you can leave this first. And the position of the image, this is also not the calculation part. You can leave this first of the image form. Okay. So you only have f equals to positive 12 cm, and you also have object distance of 18 cm. So object distance, what letter is that? Is it f, u, or v? Alright, good. So object distance is u. Okay, that means you have your u as 18 cm. So there is no sign for the object distance, but normally object distance is always positive. Alright, so use your thin lens formula, 1 over f equals to 1 over u plus 1 over v, and substitute the value given in the questions. So the question asks for the image, so we rearrange this formula. So we have 1 over f equals to 1 over u plus 1 over v. We rearrange the thin's formula, so we have 1 over v on your left hand side, and you bring 1 over f to the right. So you have 1 over f minus with 1 over u. So the f value is positive, so you just substitute 1 over 12 over here. And minus, why is it minus? Because we just rearrange, okay? It's not because the originally negative for the object. So minus with the 1 over 18, and then do your maths, you will get v equals to positive 36. Remember, okay, from this table, if it is positive, that means the image is real. So you got one characteristic from the calculation. And also from the question, it's not just on the thin lens, it also asks you on the linear magnification. So you use formula. Remember he, who, vu. Alright, so for this time we don't have he, who. We only have v over u. Then you use the v value you got from the first section. And then your u is given in the question. And you got the linear magnification of 2. So now we can now determine the characteristic and also the position. So image is real. Why it is real? Because the value is positive. Okay, how do you know it's inverted and magnified? This is because you have to know from the read, rim, boom, boom. Okay, so check it out and try to find why is it inverted and magnified. Okay, so let me know if you find out about that. Image is located 36 cm from the lens and the opposite side of the object. Image is magnified 2 times. This is all the characteristic given. Okay, so check it out. If you have any problem, you can contact me. So you try question B as well. Okay, on your own. Thank you.